In this video, I'm going to show you how to solve perfect square quadratic equations with one distinct solution or no real solutions. So here's our first example. We want to solve the quantity x minus 3 squared equals 0. So the first thing that jumps out at us is this x minus 3, that is squared, and we want to get x alone, so we want to cancel out that squared. What cancels a squared? Well, a square root. So let's apply a square root to both sides. Get the square root of x minus 3 squared is equal to the square root of 0. And if we simplify this, well, the square root of a square is just absolute value. So absolute value of x minus 3 is equal to the square root of 0, which is just 0. Now, if the absolute value of something is 0, then that something has to be 0 itself. No other number has an absolute value of 0 because absolute value just measures distance from 0. So this inside of the absolute value, x minus 3, has to be equal to 0. X minus 3 equals 0. And finally, we can just add 3 to both sides and get that x is equal to 3. So there we go. There is our solution. X equals 3. Okay, so here's another example. And this example is very similar. This time it's the quantity 2x plus 3 squared equals 0. But again, we want to start by canceling out that squared. So take the square root of both sides. We get the square root of 2x plus 3, the quantity squared, is equal to the square root of 0. And square root of a square is just absolute value. So absolute value of 2x plus 3 is equal to the square root of 0. Square root of 0 is just 0. Okay, now if the absolute value of something is equal to 0, then again, that something inside the absolute value itself has to be 0. So we have that 2x plus 3 is equal to 0. And now this is a much easier equation to solve. We can just go ahead and subtract 3. I want to get x alone, so subtract 3. We do that to both sides. We get that 2x is equal to negative 3. And then we divide by 2 to cancel out that 2 in front of the x. So we have just x is equal to negative 3 halves. And there we go. That is our solution. Alright, here are two more examples. First example, solve this equation. The quantity 5x plus 7 squared is equal to negative 1. So this is pretty similar to the problems that we've seen before. Again, we have some quantity involving x that's squared. So let's just go ahead and take the square root of both sides to cancel out that squared. So take the square root of both sides, and we get square root of 5x plus 7 squared is equal to square root of negative 1. Alright, so again, square root of a square is just absolute value. So absolute value of 5x plus 7 is equal to the square root of negative 1. But hold on, the square root of negative 1 is not a real number. The square root of any negative is not a real number. So as a result, we have no real solutions to this equation. Alright, on to the next example. So we want to solve this equation, the quantity 3x minus 1 squared plus 5 equals 0. This equation is a bit more difficult because now we have the squared quantity along with another constant on the left-hand side. But that's okay, because we can just move that constant plus 5 on the left-hand side. We can subtract 5 to move that to the right-hand side. So that way all we have is a squared quantity on the left-hand side. So let's go ahead and do that. Minus 5 on both sides. That way, that will cancel out that minus 5 there, and then we'll just have 3x minus 1 squared is equal to 0 minus 5, so just negative 5. And that's something that we know how to work with. That's pretty similar to the example we just did. So let's go ahead and do the same process. Take the square root of both sides to cancel out that square. So we'll have the square root of 3x minus 1 squared is equal to the square root of negative 5. And square root of square is absolute value, so absolute value of 3x minus 1 is equal to the square root of negative 5. But again, the square root of a negative number is not a real number. And as a result, our equation has no real solutions. Alright, here is a final example. We want to find the values of k for which the following equation has no real solutions. The quantity 7x plus 2 squared plus 4k equals 1. Alright, so this looks pretty similar to a previous problem. Some expression involving x squared, then plus some constant amount. K is just meant to be a constant here, so 4k is also a constant, is equal to some constant on the right hand side. So let's just deal with this in the same way that we did previously. Let's just subtract off that 4k, get it the right hand side, we'll get that squared quantity alone, and then we can deal with that by taking the square root. So first step, subtract 4k from both sides. Alright, so we'll do that. That'll cancel out that plus 4k there, and then we'll just have 7x plus 2, that quantity squared, is equal to 1 minus 4k. Alright, next step, we want to cancel out that square. And the way we can do that is by taking the square root. So square root of 7x plus 2 squared is equal to the square root of 1 minus 4k. Alright, so let's just go ahead and simplify that. The square root of a square, again, that's just absolute value, 7x plus 2 inside that absolute value, that's equal to the square root of 1 minus 4k. Now we want to be able to say that this equation has no real solutions. We want that to be our conclusion, no real solutions. And in order for that to be our conclusion, as we saw on the previous slide, we need this root here to be not a real number. And how do we make that root not a real number? What is necessary for that to not be a real number? Well, the inside of the root has to be negative. So 1 minus 4k must be negative. It must be less than 0. So now it's just a matter of solving this inequality, and that'll give us the values for k that we're looking for. Okay, so let's solve for k here. How about let's add 4k to both sides to get k alone. Alright, so that'll cancel out here, and we'll just get 1 is less than 4k. And then to get k alone here, we can divide by 4 on both sides. That'll cancel out that 4 in front of the k, and we just have 1/4 is less than k. In other words, k is greater than 1/4. And there we go. There is our solution. So these are the values of k for which this equation has no real solutions. Great, so now we know how to interpret perfect square quadratic equations as absolute value equations and gain insight regarding the number of solutions. In the future, we'll continue learning techniques to solve quadratics, such as factorizing and using the zero product property.